let's go ahead and do this last part, which is momentum impulse. So we have a 1 kilogram ball dropping. It hits the floor and it bounces back up. So we're going at 25 meters per second and we rebound at negative 10 meters per second. And we want to know the impulse. So remember from page 1, impulse and change in momentum, the phrases can be used interchangeably. Impulse is a force times time, and the effect is change in momentum. So what we're going to do here is we're going to solve for the change in momentum, and that will be equal to the impulse. So we will say mv minus mv naught, that'll be 1.2 times negative 10 minus 1.2 times 25. Clean this up a little bit. And so when we actually end up doing that, what we will get for our change in momentum is, let's see, so that's going to be negative 12 minus 30, and that's going to give us negative 42 Newton seconds as the change in momentum, but this also equals the impulse. And what that means for part B is we can use that to get the force. So negative 42 equals the force times the time. So negative 42 equals the force times this 0.02. And when we end up solving, I think we'll end up getting a pretty big number, something like 2100. That is exactly correct. Negative 2100 newtons. All right, for number 2, they kind of do the reverse. We want the change in momentum, which we can get by calculating the impulse. So we'll get the impulse, which is F times t, and that's going to be 6 times 3, F times t, let's move a little slower, 6 newtons times the 10 seconds of time, which is going to give me 60 Newton seconds. Now for part B, what is the new velocity of the object if it started from rest? Now, and again, this is the impulse in part A, which equals the change in momentum, just to be safe. Now, let's get the new velocity of the object if it started at rest, so we can say 60 equals mv minus mv naught. Putting in 0 here, that tells us that 60 is simply going to be 3 times v final, and that v will end up being 20 meters per second. Now, last question. Here, we are told we have a constant force F. It acts on a mass m for 68 seconds. The initial velocity is 10. We want to know the final velocity, assuming the force and velocity direction are the same. So we'll set up with F times t. We'll use the impulse momentum theorem from up here. Equals mv minus mv naught. So that's 300 times 68 equals 600 times v minus 600 times 10. So 300 times 68, I think that's going to end up being about 20,400. We just double check that. Yes, 20,400. That's going to equal 600V minus 6,000. So we're going to get 26,400 equals 600 times V. And that's going to give us a V of 44 meters per second. All right, G period. That is the main bulk of your homework for break. I will upload these videos, and I'm assuming some of you may be back on Sunday. So Monday would be a good day to look at these to bring to class on Tuesday.